discussed so far already today, but show of hands, who has actually worked with Docker at all? Awesome. That's more than average, I will tell you that much. In fact, I found out that somebody that actually reviewed this is like, what the hell is Docker? So that's basically where I was 6 months ago. So container chaos is kind of the final chapter in an ongoing vulnerability management system and integration between a security team and a DevOps team for a client of mine in the Cincinnati area who was kind of struggling to grasp the premise of containerization as a security team. So we were brought in actually in an infrastructure solution and got involved in this project as well. So what I'm going to be talking about today is more of a program for integrating a security team and a DevOps team than it is actually dealing with, auditing containers and stuff like that. We're going to talk about those high-level principles, but not really get into a lot of the nitty-gritty details about, running the tools and stuff like that. So that is that's my disclaimer at the beginning. I am a solution architect for Nexogen. I've been in the technology field since 2004. Been working in security by accident since 2005. My first job was working for a state organization, and they said, "Hey, we've got about 1,056K lines running a library system, and we want to replace them with VPNs." So I got to deploy a lot of firewalls for a couple years. Worked with them for a while, then moved to Cincinnati about 10 years ago. Like I said, I'm a security solution architect for Nexogen. I handle all of the security for our 800 plus clients and run our security programs internally. Brought up a couple security programs internally, such as a phishing program for our clients, multi-tenant SIM platform and stuff like that. Various certifications that nobody in here cares about whatsoever, even I don't care about them. I'm a cigar nerd, as anybody who follows me on Twitter will know, and I am very much over-caffeinated, which has been driving these two guys here nuts for the entirety of this trip. But I will go for the coffee and switch to the hard stuff after that. So this might move a little fast. So what is Docker? Right? So for people that aren't familiar with Docker, this is the best image that I've ever seen to explain Docker. And I practiced this for a long time. So this is a shipping ships. Oh, I got it right this time. So basically what Docker does is it's a Linux platform for hosting Linux platforms for the most part. You can run some Windows stuff inside it, but it really started off as a shared environment that you could containerize applications on top of. So instead of installing a complete OS to run your applications on, you can install just the prerequisites that you would need from the base image. So just that delta change from the base image is really all you need to install in a Docker container, and it gives it a lot of portability, right? So, basically at the base level, we've got the big Sinky ship that ships all the shipping ships, and that would be the Docker host. And then all the ships that are kind of stacked on top of it would be the containers. And what you can do is move those containers from one shipping ship to other shipping ships. I got that right too. I didn't even try that one last time. So it gives you a lot of portability, a lot of reliability and independence between the containers to not have to run prerequisites that you might not want to run. So you can reduce your attack surfaces, you can reduce a lot of complexity, and you can reduce a lot of utilization from a resource perspective. I've seen a cut of about maybe 30% on Docker containers over traditionally hosting applications and VMs because I'm not running a base OS. It's almost like a thin provisioning type scenario in the storage platform. I don't have to run all those extra services that I don't necessarily need just to run a VM. So it's very, very efficient in the fact that it runs applications without having to have the extras. A little bit more about Docker. Docker is a tool that can package an application as dependencies in a virtual container. That's the thing that I really wanted to read off on that quote. The rest of it, you guys can read, and if you want the slides, you can ask me for them later. But Docker is a containerized application hosting platform. So containerization is the key thing there. I can take a container, build it in dev, ship that same container to a test environment, and ship that container off to prod, right? So I can have disparate sets of networks, disparate sets of resources, but I don't have to migrate, or I don't have to redeploy applications every time I move from one stage of the software development lifecycle to another, right? So this, for security teams, can be a little challenging because the way that we've been doing processes with where we have our checkpoints, a lot of times has to do with when we're deploying applications, right? And what this does is this breaks a lot of those processes. And for security teams to understand what this is helps us to kind of get a grasp around a better program. It does allow containers to be deployed and destroyed with incredible speed and agility. That is another thing. Dev guys want to run as fast as possible, ship code, get it out, get it working, right? What do security guys want to do? Whoa, step back, all right? I got to test this. I got to make sure you don't have any vulnerabilities that I don't know about. I got to do all these different processes. These two models don't really work together very well. So Docker has broken a lot of our processes. The history of Docker, it was released as an open source platform in March of 2013. It came from a hosting provider that wanted to containerize a lot of what they were doing. Ended up becoming its own product and now its own company. It's got contributors like Red Hat, IBM, Google, Cisco. And what they're trying to do, which is really cool, is standardize a container technology across multiple different operating systems. They want to be operating system independent. So they want to say, you can ship this container to any different operating system, and this container will be self-sufficient wherever you put it. That is the end goal. It's a lofty goal, but that is the end goal. So what isn't Docker? Docker is not a virtualization technology, right? A lot of us want to think of Docker as, okay, I can say containers equal VMs. Containers don't equal VMs. Containers equal containers. So that's a core principle that we're going to have to get across here, is that there is not a VM mentality that you can apply to a Docker container that you could to a VM. It's not built to be inherently secure, right? Docker's not a security product. It does not have the types of segmentation that you have between a host and a VM that a virtual machine would have. It shares a lot of the same processes on the host machine that are run in separate namespaces, but are still running outside of the actual container. Whereas a VM would run everything inside the VM, this is actually running things inside the container and outside the container. So that it's not built to be inherently secure. There have been issues, proof of concepts around privilege escalation, breaking out of the jails in Docker, and it's one of those things where you have to be ready for Docker. And we'll talk about how to evaluate whether you're ready for it. It's not a virtual sandbox. It does behave similarly to one. Each Docker instance has its own network stack, has all kinds of safeguards to prevent the one single instance from DOSing the entire network. But it's not a virtual sandbox. Again, we have to think about this as a shared platform between the host and the container, whereas the host versus guest in the VMware environment would be different. And it's not a panacea for application hosting. We can't just say, hey, Docker, everything, ship it to Docker. Right? You have to strategically decide what applications are ready for it, what workloads are ready for it, and look at what you're going to try to run in the Docker instances. It's really good at web applications, not good for databases. What you want to look at is, am I going to be shipping this a lot? Right? Am I going to be making a lot of changes with a limited amount of time that these instances are going to be alive? And if that's a yes, then Docker is probably a good solution for you. There's a lot more that goes into selecting that platform than just that, though. How does Docker work? So until 0.9, Docker used libvirt, LXC, and systemd to access system resources. As of 0.9, libcontainer has taken over almost all of those roles. So now the Docker instance, the Docker container, pretty much uses the virtualization features of KVM that are built into the Linux kernel. And it does that through the libcontainer library. So this is a shift that happened a couple years ago that's given a lot more access to the types of performance monitoring improvements that we get out of the KVM. But it still does not it uses those same libraries, but it does not behave in the way that KVM would behave. So how does Docker work as well? A container can span multiple hosts. So you can share a container across multiple hosts, which you can't really do with VM. Limits can be placed on resources on a per container basis, which basically means I can say this gets this much CPU, this much RAM, this much network. I can limit the containers, but I can't really segment them as much as we can with a VM. Each container does have separate network interfaces. I say can, but it does. Has its own TCP/IP stack from the ground up, basically a virtual network adapter. And the namespaces feature gives a lot of that isolation between different containers, right? Because all the system processes for the container run in namespaces, and now user namespaces as of 1.10, which came out last month before last. We've got a lot better controls of running root stuff in the container, not as root outside the container, and that's a new thing that came out just about a month ago. Each version of the application runs. I don't know how this slide actually ended up back in there, so if with everybody's permission, I'm going to skip this one. Is that all right? Yeah? All right. There's kernel level controls in place, namespaces. Containers only have the dependencies. And the control groups are the part that I wanted to get to here. The control groups are what allows you to access or to control how much a specific container can use, right? The control groups are set up to give you that almost VM-like capability of assigning resources, and it also prevents that from utilizing all the RAM on a host and DOSing the rest of the cluster. So those are your almost controls. They do, like I said, segment to a certain extent, but I keep reiterating the fact that these are shared resources because it's really important to know that if you leak from one container into the host, the rest of the host is fair game now, right? So I keep going back to that because this is a very, very critical thing when you're selecting what applications to run in Docker and what the maturity level is and how many secure coding practices have been used to develop the application that you're about to ship. Okay? User namespaces is the one thing that's big change. It was experimentally released in 1.9 on Fedora, I want to say. Fedora? Yeah, Fedora. Released general public in 1.10, February 2016. This is a big patch. What this means is that we can map a root GUID in a container to a non-root GUID outside the container. And what that means is that before 1.10, if you had root privileges for a process in the container, that process also had root privileges outside the container, which was a huge security gap for applications that might be prone to credential leakage, to things like cross-site scripting. We had a lot of nervousness around the 1.9 release because it lacked the user namespaces. It was way behind. It was supposed to ship 2 years before it finally did, but it is in general public now. It has been tested for a couple months, and the client that I have that's using it is actually quite happy with the performance. We were worried a little bit about the performance hit of running these privileges outside the container, but it's been pretty good. Again, that just means root inside, does not mean root outside anymore. And that was a big change for us. The shared kernel architecture, again, is not designed with security in mind. The second one I got there, a root user in the container, is not also root on the host, right? That's changed in 1.10, but it's important to know that if you're looking at, from a security perspective, if you're looking at a Docker cluster and it hasn't been patched, because how many of us have gone in and seen old software deployed? Yeah? Okay. And me too. I go in and I still see Novell stuff on a regular basis. So, and I'm really aging myself there. The big one on this slide is that more than 30% of the containers in the Docker Hub contain serious security vulnerabilities. And this was the thing that really put a big kink in the way we were looking at using Docker. So Docker containers, you can pull from a Docker container hub, right? You can pull these, it's almost like a Git. And when one of the research firms that I have listed at the end here that I don't want to call out by name ran a vulnerability scan, simple vulnerability scan. They downloaded the container, spun it up, ran a simple vulnerability scan. 30% of them contain serious security vulnerabilities. Right? We're talking things like Heartbleed, shell shock, stuff that's been patched for a long time. And a lot of those were actually marked as the latest version as well. So this is something that a lot of DevOps teams are struggling with because they assume that these containers are going to be patched, right? And assuming that they're going to be patched has become problematic for a lot of different companies. The other problem that I've seen is there's a potential because of how rapid we deploy containers, right? How fast these processes move for things to get missed. So you might have 3 containers running that you forgot about. And I can tell you that this last week has been spent dealing with a customer who had an application running. They didn't need any more, forgot about it. It got popped and caused them a significant network outage. So one of the things that you can easily have happen in Docker if you don't have mature security processes and you don't have mature development processes is you can end up with multiple versions of these applications running with their own stack connected that you forgot about. And this is one of the things, you have to communicate well and you have to be auditing on a regular basis in order to be able to use this technology. So when I read that more than 30% thing, I looked at the stats, because I'm a nerd. I like stats. So I looked at all the images. 36% had high priority vulnerabilities of all the images in the Docker container hub, right? If you look at the ones that were tagged latest, 23% still had security vulnerabilities that ranked above a 7 CVSS score right out of the box. So I know when I see a 7 or an 8 or a 9 or I've seen some 10s, I get a little nervous. I want those patched right away. But we're deploying code to these without a lot of times giving them a second thought because it's not going to be there long, I'm not worried about it. Right? That's kind of what it looked like to me when I read that report. And my client freaked out because we looked a little bit more deeply, and they were running some of the containers that were discovered to have serious vulnerabilities. And the next Nessus scan turned up, oh, look at these, 5 new hosts that have CVSSs of 8.9. 2 of them had Heartbleed, right? So, yeah, it's really what I read into that. So again, I talked about kind of the diverging paths, and this is where I'm going to slow down a little bit and talk a lot more about the program that we built for dealing with Docker instead of talking about Docker specifically. And what security wants to do is be that checkpoint, right? Hey, stop, security, right? That's what we're good at. We're saying, stop, let me review this, and I'll get back to you when I'm ready. What DevOps wants to do is run at warp drive. And I'm so glad that picture popped up in my Twitter feed about 2 weeks ago because that was perfect for this talk. And Pronto is the guy that dropped that one for me. But we have different methodologies, right? And Bill Senf does a talk about care and feeding for developers. And I know some of you saw at DerbyCon because I was sitting next to one of you. It talks about how, as security folks, we don't really work with dev folks very well. And when I thought about that a little bit more, I thought, well, I wonder what tools we could put into place to improve that relationship, right? To say, I understand you're running on a life cycle, and I'm working in a reactionary method, right? I react to situations. I can be proactive, but largely I'm reacting to new vulnerabilities on a regular basis. I'm reacting to new code that you're putting into place. My proactive measures are usually at the edge, compensating controls for stuff that you have business processes that need to run insecurely. Dev, they just want to ship, right? They want to say, I've got this, I built it. It works. QA says it works. I want it out. I want it out there. Right? So how do we manage those two different goals? Right? 95% of conflict is in communication. So what we don't do, and what Jason explained earlier, that we don't do really well is communicate with those devs to say, hey, this is why we want to do this stuff securely, and this is why we need this time to run things. But Docker, in the way that it ships, is a lot more friendly to security teams because we can build in checkpoints, and because we're taking containers through the whole life cycle, I can check the containers less frequently than I was before, because I'm not deploying to 3 separate VMs. I don't have to harden 3 separate VMs. I don't have to do vulnerability management on 3 separate VMs that we're continuing to deal with here. It shifts my resources a little bit more effectively than the traditional method of shipping code. So I came up with a security process for our client that had 4 phases. The first one was discover. Second one was analyze. Third one was deploy. And the fourth one was audit regularly. Because we all like to check, right? We all like to make sure that we're keeping on top of things and that we're watching regularly to see what's happening in these containers. And that's the maintenance phase. But really, to get them to the maintenance phase, we had to have this process to decide whether we wanted to even move a workload into Docker. So the discover phase was really about deciding whether or not we were ready for Docker as an organization. Okay? And as an organization, we looked at things like, what are my development processes? Okay? Are they mature? Do I have developers who code in a secure manner? Do I have developers that have robust fallback options? Okay? Do I have a good, effective communication system between dev, QA, production, and security? Because with how rapid Docker instances are created and destroyed, we have to communicate really well in order for us to keep these instances running in a secure manner. Then we got to also decide whether the apps are ready for Docker. Because again, Docker doesn't run the way VMs run. Do we ship through defined processes? Right? If I'm building, is my development lifecycle actually mature? Right? I've seen a lot of people say, oh, we're agile. Okay, you're agile. I get it. But, you know, what's the length of your sprint? Well, it depends. Well, it can't depend. Right? What do you do on a daily basis to show me that the maturity is there to maintain, create, maintain, and destroy these containers in a reliable basis? Okay, and reliability is the key thing here in getting the devs to understand that we can't have multiple versions running. We can't have certain things that are going to enable us to say, okay, we're going to run with this tool when you're ready. Okay? And then you have to look at the apps. You have to look at, is there a potential for privilege escalation? Am I good at rolling out apps without any relics? Right? Because we're not installing a new version or patching a version up to my new code. I'm shipping a brand new container. Right? So realistically, you know, from a test to production or test to QA to production, shouldn't have that, right? But I've seen certain instances where databases, because, you know, PCI and other things don't allow you to use live data in testing phase, right? So databases are much different in production than they might be in QA. Sure, the tables are the same, the store procedures are the same, but when you get into a big data set, they can behave a lot differently than what your test data might behave in. So if you don't have really good test environments, you're probably not ready for Docker, right? You're going to need to have a much more defined process to eliminate any of those relics that you might have when you ship code from VM to VM when you move to a containerized technology. Also look at, my voice cracked. Also look at what will reside in the Docker instance, right? Do I have secure jails in place? I can't tell you how many times I've come in and asked the client, all right, so do you have SSH access enabled to this server? Well, yeah, I got people that have to dump, batch processes into the server to be processed once a night. All right, so I'll look in a little bit further, and the failed ban daemon isn't running anymore. Hey, did you guys know that you don't have any jails in place on this? If somebody logs in 3 or 4 times, they're not failed banned? No? Okay. Hey, look, I just browsed 4 different containers or 4 different clients via SSH because your jails aren't secure. Just move laterally across clients. So look at actually how well not only the application itself is running, but what's in behind it. What NAT policies do you have on the firewall pointing to the application you have now in order to enable people to do business the way that they've been doing business, not necessarily the way you want them to do business, right? Because we see these, we do a lot of compensating controls and security. Developers do a lot of the same stuff. Well, I can't do this now, so I'm just going to spin up an SFTP server and people can dump the files in and I'll parse them. What? Right? But it happens. And that kind of thing is not friendly to this type of technology. In that respect, I would not put any application or server that requires a type of SSH access or FTP access or anything like that. Wouldn't put it in a container. Maybe a little bit more now that the user namespaces are involved, but not necessarily comfortable with the potential for my root password to be leaked and to allow that type of lateral movement between the GUIDs. So again, in 110, we might be able to be a little bit more lenient on that type of functionality, but still don't necessarily trust it 100% until it's a hardened, trusted technology. The other thing to know is, will an existing container or an existing audited container satisfy the requirements? So when we start this process of actually securing Docker, right, what we're doing is we're going to pre-check. Anybody have a TSA pre-check thing now so you can fly faster? It's awesome. Yeah, I see a big shake. Yeah, I agree. We can do almost a pre-check method for containers, right? Where if my developer wants to use a container, I can say, hey, these different containers in the Docker hub, I've audited, I'm comfortable with, and you can use these containers until May 31st, right? And I'm cool with you using these containers until that time, all right? And then I'll re-audit all the containers or any of the new containers to make sure that I am pre-checking those for use by the devs, right? So if I have to build a new container to do what you need to do, that's going to slow this process down, and this workload might not be ready, okay? So this is the kind of the analyze phase of deciding whether or not we now move a workload into Docker. We've gotten to the point where we agree that Docker is the right fit for the company, right? We agree that our processes are mature enough in order to be able to utilize this type of technology. Now we're actually looking at the applications and saying, all right, which ones are we going to ship? Which ones are we going to start using this methodology in? And this is giving us kind of a baseline of, these are the apps that I'm going to move first. Because I'm not necessarily comfortable with having to build custom containers all the time with the way that we're shipping these applications. The fallback is going to be, if I need to build one, I'll just grab one and it may not be in the list. So we want to make sure that we have controls in place that say, if it isn't in the list, it doesn't happen, right? And if you need a custom container built, security's going to have to check it out first, and that's going to set you back a certain amount of time, probably a week. Now, a lot of us are busy, might be more than a week. I know I couldn't get to one in a week. So that's the analyze phase of what we do to kind of prepare a application for Docker. We then set our standards, right? What are my acceptable containers from the marketplace? What are my standard OS builds for the actual hosts, right? Am I going to standardize on a single platform, which please standardize on a single platform. It will make everybody's life easier. And what versions am I going to run? And then what versions of the dependencies am I going to run? And I put OpenSSL in here, and I was going to put more, but I then decided that OpenSSL was one of the ones that's just been getting beat on, bad, right? And I wanted to highlight that. What version am I going to standardize on across all of my platforms, right? What version am I going to give that pre-check to in order to make sure that I'm comfortable with the way that things sit right now? And then we also we can't just set standards and then say, that's the standard, right? We have to have automated processes, or not automated, but we have to have timed processes to re-evaluate what we've pre-checked to make sure that we're still in a known good state before we actually go and start utilizing this in a much more widespread manner. So I like to use a tool like Linus to audit my builds. I can take Linus and I can make that, I can say, all right, whatever the best practice analysis shows me on the Linus report is the way I want these boxes hardened before they go out. So I can check those on a regular basis to make sure that they are maintaining what I've put forward as a baseline privilege. And Linus has different definitions that you can use. It's a really powerful tool. It's also got a container plugin. So now I can audit my containers as well to make sure that they're up to my best practices. Right? So this is a really fantastic tool that helps us a lot with dealing with things like version changes, things like secure configurations of different protocols. It'll check for SSL stuff. It's really, really helpful. I used it a lot when I was working in the banking industry to harden a lot of hosted applications, internally hosted applications on a variety of Linux platforms. So a friend of mine, Michael, actually runs the company that does that. He's a really, really good guy and has done a lot in the Docker space recently to help us get a handle on things. So if you don't follow him or check on his Sysify blog on a regular basis, I recommend him highly. He's a fantastic guy and very smart Linux guy. So now I've got an automated scanner, right? But how well have I implemented it? Okay? I'm checking I've got this automated process, and I meant to say process. I've got this automated process that says, all right, I'm checking these things regularly, but I've got a tool. Am I using it right? If you look at that, I don't know if anybody's an aviation nerd like I am, you see that that's really not going to do much of anything, right? It's not installed correctly, and it's not been checked, right? And I just really like that picture. I wanted to get it in the slide deck. No, I'm kidding. So I've got this automated system now to check my containers. I've got a scanner checking my containers like Linus. But if I don't know what my configuration standards are and I'm not actually checking them on a regular basis, that can run away on you pretty fast. The other thing, from an audit perspective, and I know one person in here is going to probably roast me for this one, but we need to make sure that we're auditing containers on a regular basis. And this was the linchpin to this entire thing, right? We've got to the point where we're now shipping code, okay? And this slide is going to take me a long time, even though there's only 5 lines on it. But we're shipping code, right? Where do we now work our way into the process, into the life cycle, right? Where do we insert ourselves into the development life cycle to work with those guys, right? Not work against them. Don't make it adversarial. Say, hey, I understand you're in this cycle. I need this amount of time in your cycle, okay? And where do I build in those checkpoints to enable them to do their job, but yet enable me to be able to effectively manage the security, right? So we actually can integrate ourselves into the software development lifecycle because we're now not necessarily in a security mode. We're in a consultative mode. We're working with them, and we're inserting ourselves into the process. And this is what Bill talked about so eloquently to explain that, they work on schedules. We work in reactionary. I can build in my checkpoints with Docker because I have the controls in place from when I built that container initially to be able to say, all right, you can go to QA, but you can go to QA through us. And Docker allows us the functionality to say, ship it to me and ship it to QA. So you've put in, I gave you a Docker instance here. It's phase 1. I gave you a container that I pre-checked that said, this container is good to be used for this amount of time, and you'll ship new code on top of that before this container needs to be destroyed. They develop their software, push it out to that. Before it goes to QA, I can then run my automated vulnerability scanner against it again to make sure that nothing has changed in the time that they worked on their dev cycle to the time that it got to the QA stage. And I can actually stage that, move it right off to QA in a relatively efficient manner. Right? So it's like a checkpoint. We get that checkpoint, but we've scheduled that checkpoint now. As opposed to just hitting the boxes all the time and then saying, hey, by the way, OpenSSL is no good anymore. You need to redevelop everything in order to use Libre SSL. Right? We're inserting ourselves into strategic places in order to prevent that stuff from becoming us running around with our hair on fire. We have to look at this as we are inserting ourselves into the process as opposed to just hitting them constantly with requests, right? We have to work with them instead of against them in order to make sure that everybody's happy. And Docker gives us the ability to ship things in a manner that I have a lot less of attack surface to manage, because if I have one application, I really have 3 containers that I'm dealing with. And those 3 containers can be created and destroyed as needed. So this gives us the ability to integrate better. But we do have to do things like auditing them before they ship to production and auditing them on a schedule. Right? I know all of us here are vulnerability scanning on a regular basis, right? Yeah? At least. You can't protect what you don't know, right? That's a big deal. But are we doing it on a regular basis that's automated? That's going to say, hey, I understand your process, this is my process, let's make them work together. And this is an opportunity for us to do that. But we also have to do active attacker pen tests to make sure that there is not anything in my application that is going to let my Docker hosts get owned. Really don't like it when that happens. I don't think any of us really do. But we have to be, because we are losing a lot of the security functionality that we're accustomed to, we need to be doing more pen testing and doing better pen testing. Then put a vulnerability scanner like Nessus in, right? I had Nessus in here. Twistlock has come out with a product for Docker over the past couple months, year, that does a lot of this for us now. It's really good stuff. I've spoken with their chief strategy officer several times. I've evaluated it thoroughly. I evaluated it with my client. My client is going to buy into that technology on a pretty wide scale basis. And they do things like vulnerability scanning, runtime defense, compliance, and access control, which are things that traditionally dev teams kind of struggle with, right? DevOps teams kind of struggle with. You know, they'll share. How many of us have a policy that says, thou shalt not share credentials? All right? How many of us share credentials? Oh, come on. There's got to be somebody that's got an admin account out there. No? Oh, I saw a smirk. All right. It happens, right? And dev teams are going to say, hey, just here's the root password on this container. You know, we're not going to set up all these accounts, right? We're not going to set up accounts for shipping code because it just takes us too much time. Just use the root password, right? So Twistlock makes it easy, does the vulnerability scanning for us, and gives. What I really like about it, and I don't mean this as an ad for them, because I don't have any affiliation with Twistlock whatsoever. I just really think that it's interesting technology because it gives the devs visibility into the vulnerability scanner itself, right? And what do devs want? Can anybody tell me what devs actually really want in a security process? Transparency. Spicy food and beer, yes. Expensive, fancy, flowery beer.
Not to know it's there.
Not to. Be invisible. I used to think that was exactly the case.
Well, unless it doesn't.
Well, what I found out though, and I talked to the dev staff there. I bought them a lot of spicy food and beer. Some of the beer had chili peppers in it, and I drank one, and I was like, wow, how do you guys drink this stuff? What they really wanted was to be educated, right? They don't want to continually get owned by the security team, right? and a lot of them are like, you know, I'm trying to make my job, trying to do my job here, ship code. I've got these I've got these use cases stacking up. I got a schedule to get on, and you guys just keep pissing on me. It's like, yeah, but, you know, we used to just say, yeah, get over it. Do better. But what they really wanted was to be educated. Like, how can I do better? So that you guys have less stuff to come to me and say, hey, fix this, right? They want to be educated. And what giving access into the vulnerability scanner gives you, from the dev side, is the ability to look at these things and not just get a report from the security team showing how much you suck, right? What it gives them is the ability to look at, hey, if I do this, how does that impact the vulnerability scan? And they can do it on a much more consistent basis. And I've actually seen them buy into vulnerability scanning and actually take it seriously when they can be involved in that actual tool, right? So that's something that we can integrate this kind of technology into a DevOps team and get buy-in. And buy-in is critical. It's king, right? If people don't buy in, they're not going to make a change. And if they do buy in and they feel like they're participative in the process, they're going to be much more receptive to what the security guys come and say. And if they're solving problems that we're going to bring to them anyways, before we have to bring them to them, it makes our jobs easier, right? Because they're looking at the vulnerability scanner saying, well, I can patch this, or I can fix this, and they fix it, and I never have to talk to them. I can focus on the 387 tickets I've got saying, hey, the firewall's broken. Probably because I broke it. And then as a security team, I do like using Linus, and that's because, all right, so we've got the development team, then we've got the operations team, right? And then we've got a security team. And I'm sitting here in security world saying, you know, hey, I checked all these configurations and they're all broken. So the operations team, the network team, they don't want to be bothered with that stuff either. And as security guys, we're saying, hey, well, you know, you need to fix all these servers now, right? So they asked me, how do I get these servers better before I put them in and have the security guys look at them? So I only have 3 things to fix before you guys come back at me. You know, because, you know, they were getting dinged on reports and stuff for shipping bad servers. So I said, well, try Linus. They said, what? I said, install Linus, try it out. It'll give you a baseline configuration that is solid for the hosts that we're going to be shipping code to. We are going to be happy with the way that these hosts are configured, primarily happy with the way these hosts are configured if you run a tool like this before you tell me that it's ready. If you say, hey, I built a new instance, it's ready for you, great, I'm going to check it, but this is going to allow you to be participative in the process of getting that box hardened before I have to look at it. So when I come back to you with 3 things that need to be fixed instead of 30 things that need to be fixed, it's going to be consistent, and you're going to be part of the process. So you're going to understand why I'm doing these things on a regular basis. Right? Everybody kind of cool with that? Good? I do have some references here. We're way ahead of schedule because I am over-caffeinated. So the Red Hat blog, what's next for containers, user namespaces, explains a lot of what that user namespaces feature does, and it does it in a much more technical manner than I did because, you know, I don't have 60 pages to talk to you guys about. The second one, the Analyzing Docker Hub, is the source for that study that was done. If anybody wants these, I've got my contact info on, I think, the next slide. Maybe 2 slides. The Banyan Ops one is the Analyzing Docker Hub. That is a great study that if you're going in as a security team and saying, we're not ready for Docker after today, right? You can take it to them and say, hey, look, there is a significant problem in the Docker Hub with vulnerabilities. And if we're going to adopt this tool, we got to be proactive towards this type of situation, okay? And then the last one, the Docker shipping and container for Linux code, that's kind of basically a how to Docker 101. I really like that article. I've read it several times over and over to make sure that I wasn't misunderstanding some of the processes that were in place. And Really, really like that one, so I like to put it up there. The other thing that I have here is the Sysofy / Linus. That is Michael Boland's site. He is he has kind of gotten into the Docker auditing functionality. It's open source. He's a really good guy. Check it out. His blog is also fantastic if you want to learn about Linux hardening or Docker hardening. Twistlock is the company that I talked about. That is not open source, but it's very, very cool. And it's a very easy tool to integrate your security team with your DevOps team and get some better results. And then the care and feeding for developers, Bill Semp's talk from DerbyCon 5? DerbyCon last year. That was a great talk about how to kind of deal with those guys. The spicy food and expensive weird beer. That's kind of the gist of it, but this really gives us a real good understanding of what developers want from us. Right? So this talk kind of spawned out of watching him at DerbyCon last year and thinking, yeah, you know what? We suck sometimes. We're really good at making things secure, but we're not necessarily good at talking to people about why we're securing things. I can't tell you the number of times I've gone into a meeting and I've heard, well, I would do it, but the only answer I get is because security. Right? And I'm guilty of saying it when I was younger. We don't want to explain things. We just want to say, well, it's security, dude. Do it. Right? So this will kind of help you explain and educate your team. I am at LinkState on Twitter. There's also a Safe for Work. I hesitate to call it Safe for Work, but a lot less of my random musings at Chris on Security. That one's the one that I'll probably be pushing the talks out to and some of the work that I've been doing. The other one is the best way to get hold of me. Or you can email me at cjh@nexogen.com, and I usually get back to emails within a week or so. So, Q&A is the last part. Questions?
I was just going to throw out there that you threw Twistlock up and you didn't want to sound like a commercial. Well, they do have one competitor, so I thought that would help make it.
Yeah. I've only evaluated Twistlock. So.
Scalelock is really the only other competitor I've seen that's out.
Yeah. Have you looked at him at all? Or?
Yeah.
Good.
Comparable. I mean, same approach. It's like everything you need for Docker in one product. So
right.
A bunch of different things going on all at once, so you don't have to get a bunch of different products. Existing stuff.
Great. Yeah, that's just I haven't really looked into.
I think they're both Israeli, so.
Yeah. I know Docker has most of their offices out in California right now, but yeah, I really liked what I've seen out of them. I just haven't evaluated anything else yet. And as this project is tailing off, and this is the last time I'll probably be giving this talk, it's probably not going to make it in there, but I will look into that. That's
great.
right.
Change your name because they're both blocked.
Yeah. That's not confusing at all.
But they're scale.
Yep.
How feasible, easy, viable, maintainable is it to just run your own private image registry as opposed to using the public Docker?
Relatively easy. The thing about it is that with a lot of code coming out of GitHub now, people pulling stuff down that they're utilizing, it's kind of become ingrained in the DevOps style to use repositories like that, to use public repos. So because of that mentality, again, we don't want to say, we don't want to break their processes in order to integrate security. And it's not difficult, but we would break a process for them in the fact that we want to just integrate. So, the way that we ran it is, hey, tell me which ones you want to use. Because realistically, there's going to be 2 or 3, right? Tell me which ones you want to use, and I'll say, okay, or no. And if you want to use a new one, again, will the pre-audited container satisfy my requirements? Yeah. Yeah, they have a short list to pick from, so then they can say, I say, you're good with this one until this date, right? So if they're running on 4-week sprints or 2-week sprints, I can predict that I'm going to need to pre-check a container for 6 weeks. So I have 2 weeks in dev, 2 weeks in test-ish, and then 2 weeks in prod until the next one rolls in, or 4 weeks, however long it might be. I can predict how long I need to say this is good for. Now, there's going to be situations where something like poodle drops, right? And we're going to have to say, hey, remember how I told you this process, and I'm going to integrate with your process? Yeah, well, this is really bad. So we're going to have to ship something new, or we're going to have to patch on the fly here because we've got a problem, right? And I'm going to focus really hard on finding a compensating control in that case, where I'm outside of the Docker containers in order to make sure that I'm getting some kind of security put onto that vulnerability. So, in the SSL vulnerabilities, the SSL offloading on a lot of WAFs was really helpful because I could patch the WAF, and for the most part, I'm okay now, right? Until I ship new code that's built on a new version. I've got that 2-week stopgap of a compensating control.
That's in line with the whole one process that Dr. Klofsky, just keep each thing separate so that you can swap it out.
Right.
And that makes it all easier.
Yep. So, we had really good reception on this. The DevOps team felt involved. They're really feeling a lot more involved now that we've integrated some twist lock functionality. We haven't had them start using the entire stack yet. We just wanted to get vulnerability scanning because we're trying to get buy-in, right? So we thought if I involve them in the process of vuln scanning, then they're going to start asking me about the other functionalities, right? So, and it's been really good. They've actually been catching stuff. They've been catching stuff in the vuln there that we get in the Nessus report the next morning. We say, hey, can you patch this? And they're like, I got it last night. So that's pretty cool, right? From my perspective, that container is still in dev, right? They're patching in dev containers. I can't tell you the last time I saw a VM patched in dev before I started squawking about it. So, anybody else? Questions? The process is very, very similar to patching a Linux server in that respect. Really, it's apt-get or whatever you would be running in your version of your flavor of Linux. You can build on top of them. They don't sit in a frozen state. Sometimes I wish they would, from a control perspective, from a, hey, this is what I said is okay. I get that you're 2 versions beyond that, but there could be potential vulnerabilities 2 versions beyond what I said was okay. We don't see vulnerabilities exposed, new ones exposed in new products a lot, but there's a potential there for somebody to misconfigure something in a new version. Right? So they're not in a frozen state. I wish sometimes they were, but from a perspective of being able to patch on the fly, it's really helpful. So, anybody else? Yep.
What about, so in that situation, what about like unit testing and functionality testing? Because we don't necessarily see new vulnerabilities, but sometimes we see breakage.
Yeah, we see breakage. A lot of that stuff was integrated into the QA process. I will, because the containers can be cloned pretty easily, I've recommended that if I can get a compensating control in place, that I don't patch a production container just right out of the gate. I'll clone the production container, ship it back to them, or ship it to a security environment, patch it, send it to QA real quick to verify functionality, and then ship it back out as well. That's why I really like to, with these kind of containers, focus on compensating controls and how I can better mitigate the vulnerabilities that I might have in the prerequisites that I have running, or the software that I have running, in that I can offload a lot of that outside of the containers. So that's part of my analyze phase is, if I have certain things like FTP access or something like that, or if I have a specific software package that just doesn't really run on the newest versions, probably don't want to put it in Docker to begin with because I'm going to have to patch it a lot and I'm going to have to functionality test it a lot. So, yeah, we see a lot of breakage still. I mean, it is what it is. We still see patches breaking stuff. It's a shame, but we do.
So help me understand, like, as you went through those phases, like, how much of that is automated and how much of it, the security team is still touching things and really looking at things, and like, what's the general, given like one run through that process, kind of timeline, where you you seeing in this?
Right. So once I kind of got that pre-check method in, I saw a lot of workload. No, with the Docker container, the vulnerability scanning, and the Docker Hub, right? So once I pre-checked containers, I was able to step back and not have to pre-check things in the beginning. Because I've said, okay, you're good with these until this date, and I'll renew that pre-check at this date, or I'll roll out I'll tell you to go to this newer version, right? So that, for me, I could step away from having to build a new VM for them, right? So I'm letting them handle that process. So that's now not automated, but I only have to touch a container in the Docker Hub once for me to be comfortable with it, right? I only have to touch it once. So they could use it 50 times. I've only had to touch it once. So it's not automated, but it's more efficient. The vulnerability scanning has been automated, right? I'm checking everything on the network in an automated fashion in a certain time frame. Shipping is obviously not automated because I need to have that 2-key system to ship code, right? 2 people need to say, I'm okay to ship this before I ship it. So not a lot of automation, but a lot more efficiency, I guess, in the process. And that, we're enabling something to be a little bit more agile. We're enabling them to work in a way that devs want to work, yet still getting our security requirements in place. Does that make sense?
So I think so. So the hub is essentially like an abstract. This is something you've already approved, and you publish it in a way that they can just go and use it.
Well, yeah, they can.
And they don't see it until you're done with it. You're fine with it. You push a button, and it's available to them. Right?
We didn't have it to that extent. What we had is they can grab them out of the hub. It's almost like a Git repository for containers. What they did is they submitted a name, a container name that they wanted me to use. It has an ID number. They said, hey, I want to use this one. This meets all my requirements. Can you check it out for me?
So they send it to you.
They send it to us. We pop it into a test environment, run an ASV or a vulnerability scan against it, make sure it's okay, make sure it meets our requirements. That we're meeting our established baselines for versions of prerequisites and everything else. And then we can say yay or nay. And say, all right, this one is now pre-checked. You're allowed to use this for this amount of time. Grab it as much as you want out of that Docker Hub, but this one is okay. So it integrates into the way that they want to work in a way that we can feel comfortable with it.
But if it's not okay, does it bounce? You have to go back and forth, and they fix it, or do you?
Typically, we'll find a container that we can use. There will be something that is out there. I mean, there's hundreds of containers. Typically, we'll find one that's okay. And honestly, we had one kick back, say, hey, no, that one's got Heartbleed. Right out of the box. It got popped, right? Oh, okay, well, that was just a little bit smaller of a container. I can use the one that you already pre-checked. I was just trying to save, 50 meg of disk space. I'm like, 50 meg? We got a 48 terabyte SAN, and you want to save 50 meg of disk space. So, it was one of those funny things where like, yeah, I'd like to use this, but there wasn't really a really good business case for it anyways.
So you're starting from public images. You're not
We're
custom.
We're pre-checking public images because that's how, a lot of the stuff that the devs are grabbing code from GitHub. They're grabbing little code snippets, right? They're used to searching for things that are pre-built for them so they can shortcut having to build everything custom, right? And that's what we're trying to enable from a security perspective is we're going to say, hey, I love that. Let me help you figure out which ones are cool. Anybody else? Yep.
I'll just comment on that theme about basically having someone with security in mind, pre-qualifying some dependency, and basically putting a stamp of approval on it before it goes into circulation within the process, whatever. There's a similar parallel discussion in just dependency management in general, like we're talking
Right.
where we had this thing with Node.js package manager.
Yeah, where it got pulled down and
Someone pulled a package.
yeah.
Because they were pissed off that there was a copyright.
I remember that.
Copyright or something.
Yeah.
And they just said, no, I quit. They pulled their code.
Yeah.
And all these major libraries depended on it.
Yep.
Well, no one was checking to see if it made sense to even include that in the first place.
Yeah.
But it raised the discussion about, wait a
Yep.
And like we're sort of having that discussion with the software community about like, well, can we have a process where dependencies are reject and we actually only automatically build our process stuff.
Right.
And who trusts it, you know? So like I think we're going to end up evolving towards some sort of universal dependency management system where things can actually be verification where I trust your opinion, but not their opinion. So if you say it's okay, I'll use it, but I don't know this other person. So
Absolutely.
you know, so we could potentially get to that point, but I think we're just beginning to like start thinking about what the technical capability is.
Yeah, the Node.js one was funny because I got like 3 calls saying the firewall's broke. I'm like, no, it's not. Your code's broke. No, it's firewall. No, no. Let me look, because I made that comment earlier about how, you know, I spent so much time trying to prove it wasn't the firewall that I completely missed the fact that it was the firewall. I had misconfigured an app policy, and it's entirely possible. However, I looked and nobody had been on the firewall for weeks. I've seen sometimes where IDS updates can cause some wackiness, but all of a sudden I got the same call from 5 different places. I'm like, all right, now this ain't a firewall problem in 5 different locations, and it turned out that they had grabbed that package. It was pretty common. So, you know, that it was surprising to the devs when I came back and said 30% of those images in the Docker hub have vulnerabilities, serious vulnerabilities, like CVSSs of 7 or above. They're like, oh, really? I'm like, yeah. I mean, it's not a secure platform to begin with. And that was like, oh, well, you know, we have, that brought up the same discussion, and we came to a conclusion that if we can do a pre-check, we'll be much more successful in the long run in integrating. So that is very much where that discussion came from. Anybody else? I think we're out of time. They just gave me the disowning frown.